Hello Year 4s, welcome to your video about shape. Now this is particularly focused on the pages 52 and 53 from your CGP workbook, which you've been set for this week, and this is to help you with the different types of shape that there are, because I know that some of them you haven't learnt yet. So you can see on the screen a picture of some quadrilaterals. Now I wonder if you can remember what that word means, because you might have heard that before. And if you can't, a quadrilateral, if you look at the beginning of the word, quad means four. So a quadrilateral is a four-sided shape. Now, I'm not going to go through these in detail because you can spend time pausing the video and looking at these with a bit more time, but I just want to highlight a couple of the shapes on here. We know obviously square and rectangle. Now, a parallelogram has opposite sides which are parallel. Now, if you can't remember what parallel means, it's where two lines are opposite each other and they're the same distance apart the whole way along. So they don't narrow to meet each other. They stay the same distance apart. So if you imagine train tracks, they are parallel. And so in this shape, the parallelogram, the sides that have the two lines on, they're both parallel to each other. They are slanted, but they're still parallel. If you drew the lines longer, they would continue on the same direction and wouldn't get any closer together. And then the lines that have one orange line are also parallel. So the opposite sides are parallel, and they are equal in length. The opposite sides are equal, and it also means that the opposite angles are equal as well. Now, a rhombus, which is next to it, is a special type of parallelogram where all four of the sides are the same length. So in a parallelogram, it's just the opposite sides that are the same length, but in a rhombus, it's all of the sides are the same length. And it's a little bit like, they're still parallel, but it's a little bit like a square that's been squashed. Sometimes looks a bit like a diamond, but it is a bit like a square that's been squashed. So all the sides are the same length, but you've still got your parallel sides. Their opposite angles as well will be the same. Now, down the bottom, we've got two types of trapezium. Now, there are lots of different types of trapezium, but the ideas are kind of the same. With a standard trapezium, there's two sides that are parallel, and in the trapezium on the bottom left, the sides that are parallel are actually the top and the bottom. Now, even though they're different lengths, they're still parallel, because if you drew the lines longer, they would continue that same distance apart. Now, in a standard trapezium, you might not have any of the side lengths and angles that are equal. However, in the trapezium that's next to it, which is known as an isosceles trapezium, which is a very posh maths word, and actually relates to a type of triangle, which we'll learn about next time, or later actually. The isosceles trapezium, you have two sides that are parallel, as a normal trapezium, but there's also there's two sides that are the same and the angles are the same at the bottom. So it looks less skew width, it looks more standard. So they're the type of trapeziums you might see more often, that kind of shape, wider at the bottom and narrower at the top. But a trapezium can look in many different forms. We've got a kite down there. Again, you can spend time to look at that more closely, but there are two pairs of sides that are equal in length. And then we've got the quadrilateral on the end, which is an irregular quadrilateral. So that's just any shape that has four sides, four straight sides. The angles and the sides don't need to be the same, but it will just have four sides. So it might look a bit wonky. Now, I'm going to show you a link to a website which Mrs. Buchanan put on her learning grid. It's a bite-sized link. I will also put the link underneath the video in case you can't find it, but it will talk to you more about shapes and polygons and what they actually mean. So let's have a look at that now. So this is the bite-sized website that I mentioned, and the link is on your learning grid for this week in the last column, but I'll also put it underneath underneath the YouTube video so you can access it easily. So it tells you about different types of polygons and their names. So there's a video for you to watch, which will tell you some different names. A polygon is a 2D shape with straight sides, so not a circle, but other 2D shapes that have straight sides. And so it will mention to you different names of the different types of quadrilaterals, and it will talk to you about triangles, not in a lot of detail. I will go into that next, but it will go over quickly the names with you and also go over what regular and irregular polygons are. If you carry on scrolling down after you've watched the video, there is a little fill in the gap quiz where it will give you a kind of a clue to a shape, and then you need to choose one of the three from the top to type into the box, and then you can click on check. So there's 5 questions there, and then also there's a true or false quiz at the bottom which you can play as well. So this is a really useful page to learn about different polygons, and I do recommend you using this and the picture that I just showed you at the beginning to help you when you're working through your workbook for this week. Use it as a reference, use it as a guide. You're not going to be able to remember all of the names at once, so do keep checking back as you're answering the questions in your workbook. Use this website and use the picture at the beginning of the video to help you to answer those questions. Now we're going to focus mainly during this video on our 3-sided shapes and the different names that they have, and their names which are useful to learn and you will need in your workbook. So let's go over to that now. So we're going to start with triangles. Now we haven't talked about the different types of triangles in class, which is why I want to particularly focus on it here, because you have some questions in your book about it. Now, there are different names for triangles, and some of the names are quite tricky. And unfortunately, they're the kind of things that you just have to learn and find funny ways to learn the funny names. But some of the names are quite cool. So it's going to be quite exciting to learn some posh new maths words. Okay, so let's see how we get on today. So we've got 4 different triangles here, and you probably didn't even think that there could be so many different triangles with so many different names. But here we go. We're going to start by having a look at the equilateral triangle. And the equilateral triangle has got a name which actually does help us to remember what it's about. So let's have a look at that one. So the equilateral triangle has 3 equal sides and 3 equal angles. Now we're going to be doing more about angles soon, but you can see that inside that triangle, between where the 2 lines meet and the amount of distance they've opened up, we've got 60 degrees in each corner. Okay, we know about 90 degrees being a right angle, but these are 60 degrees. So they're all 60, they're all the same, and all the sides are equal as well, and that means they're all the same length. Okay, not that they're the same colour, but they're the same length. And these double lines that you can see on here just show you that they are the same. Okay, it's just a way of showing you that the sides are the same. Now, because it's the same, that means that it can be rotated around and it will look the same each time it's rotated because it's the same everywhere. It also means that there are 3 lines of symmetry. And so if we had a mirror, we could put a mirror down all of those lines and it would look the same either side. So 3 lines of symmetry, 3 equal sides, 3 equal angles. And the name equilateral has got at the beginning equal. So that's a way to remember it. That's the most important way to remember it. Equilateral, okay, equal. Everything is equal. That's the way to remember it, okay. Equilateral, everything is equal. Now let's have a little look at one of the other triangles. Okay, we're going to go on to isosceles next. Isosceles, that's a very funny name. So we've done equilateral, where everything is equal, and now we're going to do isosceles. So an isosceles triangle has two equal sides and two equal angles. So remember, an equilateral triangle has three equal sides and three equal angles, but this has two. So that could be two long sides and a shorter one, or it could be one longer side and two shorter ones, as long as you've got two of the sides which measure the same length. Now, to me, it reminds me of a mountain, and it could be a tall, pointy mountain, or a mountain that looks a little bit like perhaps a volcano as well, that is stretched out a little bit more. But that's what I think of, an isosceles mountain. Now, the word isosceles has got two S's in it, isosceles, and we need to remember that in an isosceles triangle, two sides are the same. Isosceles, two sides the same. Okay, that's one way to try and help you remember. And we can also think of an icy isosceles mountain. An icy isosceles mountain. Now, there's just one line of symmetry in an isosceles triangle. You couldn't put a line of symmetry anywhere else to make it equal either side and a mirror image. So it just goes from top to bottom there. Isosceles. So it could be tall and thin. It could be wider, as long as we've got two equal sides, which will give us two equal angles. We need to remember that two sides are the same in our isosceles, which is like an icy isosceles mountain. Right, let's have a look back at the other triangles. So we've done equilateral, everything is equal. We've done isosceles, an icy mountain, two sides the same. Now we're going to have a look at scalene. Funny name, this one, scalene. It's not scaly, but we will find out a little bit more about it. Right, so here we get a scalene triangle. Now, in a scalene triangle, all sides are different. They're all different lengths, and all the angles are also different sizes. So all the sides are different lengths, all the angles are different. And they might look, because everything is different, they could look very different. And so you're looking for, if you're trying to find a scalene triangle, you're looking for a triangle which doesn't look like any of the sides could be equal. And because none of the all the sides are different, it means that the triangle can look a little bit skew-width, which means kind of a little bit wonky. And so that's why I remember it as a skew-width scalene, because there's no right angle, there's no two sides that are the same, and so it looks a little bit skew-width. Whichever way round it is, and there's the green and a blue and an orange one here, it's a little bit skew-width. So a skew-width scalene. Now, because it's skew-width, because all the sides are different and all the angles are different, it means there are no lines of symmetry in a scalene triangle. You couldn't put a mirror line anywhere on a scalene and create an equal image on either side. No lines of symmetry, because they are skew-width. Skew-width scalene. All the sides and angles are different. Now, let's have a look back at the other triangles. We've got one more to look at. Just remember, skew-width scalene. Okay, it's skew-width because everything is different. Right, so we have learned equilateral, all the sides are equal. Isosceles, the icy mountain with two sides the same. And scalene, the skew-width scalene, all the sides and angles are different. So we are left with a right-angled triangle, and you'll be happy to know the name is quite self-explanatory, and it's probably the easiest name to learn. So a right-angled triangle has a right angle. Now remember, a right angle is 90 degrees. It's basically a perfect corner. You can see it down at the bottom left here of this triangle. And we always show a right angle with a square box rather than a curved angle box, just to show that it is a right angle. Now, a right angle, you can look for a right angle wherever it is, because it might not be in the bottom left corner, because sometimes triangles have been rotated and they've been turned around. So you just need to look for a corner that is like the edge of a piece of paper or the edge of a book, or a very perfect corner. You have to be careful because sometimes it's almost a right angle but not quite. But that's what you're looking for. If you're looking for a right angle triangle, you're looking for a right angle, which would be a perfect corner. Now, there's a really fancy maths word I'm going to teach you here, and you absolutely don't need to know this, but it's pretty cool, so I'm going to teach it to you anyway. The longest side on a right angle triangle here is called the hypotenuse. Hypotenuse. That's a very posh maths word you can impress people with. You can say, oh, look, that triangle has a hypotenuse. Now, that doesn't mean that's not a hippo. No, not a hippo. A hypotenuse. Very cool word for you to impress people with. Hypotenuse. No dancing hippos, please. Now, this triangle reminds me a little bit of a skate ramp. Now, remember, it might not be this way up, but when it is this way up with the right angle in the bottom left, it reminds me of a skate ramp. Now, similar to the isosceles triangle, it has one line of symmetry. So a right angle triangle, don't really need to think of a fancy way to remember that name because it just has a right angle in it. So you're looking for a triangle with a perfect corner. No dancing hippos, remember. The hypotenuse. Right, let's go back and have a look at all four. So we have an equilateral triangle, 3 sides, 3 angles, equal. Equilateral, everything is equal. We have an isosceles, icy mountain isosceles, 2 sides the same. We have a scalene, a skew width scalene, all the sides and angles are different. And we have a right angle triangle, which, surprise, surprise, has a right angle. Now, it is difficult remembering all these 4 names, so the best thing to do is try to remember most of them, and then you'll know that the one you can't remember is the other one. So, right angle triangle, pretty easy to remember, it has a right angle. Equilateral triangle, everything is equal. And then you need to think about, is it easier to remember a skew width scalene with everything different? Or can you remember an icy mountain isosceles with 2 sides the same? Because if you can remember 3 of them, you'll know that the remaining triangle is the other one. Now, I'm going to test your knowledge of triangles now by looking at these pictures, and we'll see if you can match up which triangle, which little triangle character is which type of triangle. So we have here an isosceles triangle, 2 sides the same, an icy mountain, an equilateral triangle where everything is equal, a scalene triangle, a skew width scalene when there are no equal sides or angles, and a right angled triangle which has one of the angles as a right angle. Now, I want you to have a look at these pictures and see if you can work out which is which. Now, some of them have been rotated round, as I said would happen, but you can still look out for those key properties. Remember that an equilateral triangle will be equal all round, so that all the sides will be the same. Remember, a right angle triangle will have a right angle somewhere on one of its points. A scalene is going to be pretty skew width and nothing will be the same. And your isosceles triangle may be tall and thin, or it may be wide, but we need to make sure that two of the sides look like they're the same. So it won't be wonky, it will be quite straight, but it won't be as perfectly formed as an equilateral triangle. So I'd like you to pause the video, and I would like you to work out which number of our triangle characters here on the left matches the names on the right. And then I will reveal the answers in a moment. So please pause it so you've got some more time. Take as long as you need, and then play the video and we'll see if you're right. Okay, so I'm going to reveal the answers now. So if you're not ready, make sure you've paused. So here we go. Number 2 was an isosceles triangle. You can see that two of the sides are the same length. Okay, it's more of a tall pointy mountain, this one, an icy isosceles mountain. Two sides are the same. That's number 2. The equilateral triangle was number 1. Now it was upside down, which might have put you off. But if you look closely, all the sides are the same length, even though it's pointing downwards. So everything is equal for number 1. The skew with scalene is number 4. You might have been able to tell that from the crazy face that Mr. Scalene has got down there at number 4. You can tell that all of the sides are different and it's all a bit wonky. It's a skew with scalene, which means that number 3 is our right angled triangle. Now this one has been rotated. As I said, it might look different, but you can see in the top right corner there is a right angle, like the corner of a book or the corner of a page. There is the right angle, which means it is a right angled triangle. How did you do? I hope you managed to match them up. We're going to flip on over to the workbook now and have a look at a couple of questions in more detail, which will hopefully help you when you're answering them. And then I will show you a game and an app that you can get at the end, which will hopefully help you even more. So now that we've learnt our triangle names, I'm just going to go back to the workbook and just go through 2 of the questions on page 53. As I said, use the Bite Size website and the picture at the beginning of the video to help you with other questions on this page. I just wanted to talk you through question 3 and 5. So it says, draw a pentagon with one right angle on the grid below. Use a ruler. Now, I don't want to kind of give away an answer for you. So what I'm going to do is I'm actually going to draw a hexagon with one right angle. Okay, you're going to do a pentagon, but I'm going to do a hexagon, just so that you don't copy me. So if it needs a right angle, I'm going to do that straight away, because then I know I've done it and I know it's got a right angle. Now remember, a right angle is perfect 90-degree angle, like the perfect corner of a page of a book. Okay, perfect corner, 90 degrees. Okay, so I'm going to put that in first. So I'm just going to draw and create a right angle on my grid here. I'll be showing you an app later on in the video, which may be really useful to practice this before you draw it, because on the app it's a pegboard app and you can use the bands to have a go and stretch out virtually, so that you can have a go at creating a shape before you commit to drawing it. Now I'm going to do it with a pen so you can see, because I realised you couldn't really see the pencil. So I'm doing a hexagon, so it needs 6 sides. All right, so I've already got 2. So 1, 2, and I'm going to make a 3rd side down here. 3. Now it doesn't need to be a regular pentagon, or mine's not going to be a regular hexagon. It doesn't say that, so, and it's not going to be regular if it's got a right angle in it. So it can look a bit bizarre. So I've got 1, 2, 3, 4. So I'm doing hexagon, which is 6 sides. So I'm going to go 5 and 6. So 1, 2, 3, 4, 5, 6. And I've got a right angle up there. Okay, so there's my hexagon. So you have a go at doing the pentagon with the same technique. Put the right angle in first. I also wanted to just have a look at question 5, which says, here is a regular pentagon. Join 3 dots to make an isosceles triangle. Use a ruler. And then the bottom bit says, here is a regular hexagon. Join 3 dots to make a right-angled triangle. So you need to use your knowledge of triangles now to create a triangle on using the dots on this shape. Now, the fact that it's a pentagon and hexagon is kind of just there to throw you off, really. You basically just have to draw an isosceles triangle and draw a right angle triangle by joining up the dots, and kind of ignore the shape that's there. You will need to draw across the shape at some point. You won't be able to stick to the lines. So I'm just going to draw just any triangle. It's not going to be an isosceles one necessarily. So for example, if I just join up those 2 dots, and then I might use that side as well, and then I might go across. Okay, so that's basically what it means. It just means draw a triangle using the dots. This one needs to be isosceles, 2 sides the same, and this one needs to be right angled, so you need to create a right angle. Okay, and I'll give you a clue. Because this is a regular hexagon, none of these angles that are between the dots here are right angles. So you're going to need to create your right angle with a side and then a line, a side that will just cut across the shape. Okay, because if I created 2 of my sides of my triangle with these 2, okay, this is not a right angle here, and it won't be all the way round because it's a regular hexagon. So you will need to create your right angle by cutting across the shape from one of your straight sides. Okay, so hopefully that will be helpful to go through those. I'm going to go through with you now your hot chili challenge for this week, a game and an app. So this is your hot chili challenge for this week. There are 4 parts to this challenge, 4 coordinate challenges for you to have a look at. So what you have to work out is what the missing coordinates are to make the shape. Okay, so it says plot the missing coordinates to make an isosceles triangle, complete the drawing and write the missing coordinates. Now, obviously you can't write it on the screen, so you'll have to write it down and send it to me in an email. It's given you 1 dot there on the grid, but you need to create an isosceles triangle by putting on 2 more dots and then work out what the coordinate would be. So remember, you go along the bottom and then up the side. Okay, so the dot that's already on the screen would be 2, 3. Okay, so you go along the corridor and up the stairs. So you do the bottom number, then the side number. There are 4 of these pictures for you to have a look at. And I will just let that run on the video so you can skip on and pause and have a look at it. If it would be useful for to have a paper copy of these so that you can actually draw it on there, I'm more than happy to email them out. So please do just send me an email asking for your hot chili challenge coordinates, and I will send out the 4 of these little cards so that you can print and draw on them. Okay, so there's an isosceles triangle, there is one for a parallelogram, there's one for a trapezium, and there's one for a pentagon. Okay, so there's 4 there in total. Good luck. One of the extra links on Mrs. Buchanan's learning grid this week takes you to an enrich activity, which is the one that you can see on the screen now, shapes on the playground. Now, this is a really great problem, and when you first look at it, it looks incredibly confusing and really tricky. But actually, if you work through it carefully, it's not that hard. So what I'm going to do is midweek, I will produce just a little video which will just get you started on this problem, just so that you know where to begin, because sometimes with problems like this, it's hard to know where to start. So I will give you a bit of a help with this one midweek, just to give you something else to be thinking about once you've maybe done your workbook pages, something else which could extend your learning. So this game is called Triangle Shoot. Now there are 3 different parts to this game, and 2 of them involve angles, and we will come back to this in our angle section. But we're going to have a look at the bottom section here, equilateral, isosceles and scalene triangles. They're the ones that we need to find. Now there is an extra level on the end of both of these with rotation, which makes it harder, which means that they're turned round. Okay, but I'm just going to play this level for now, and you can have a go at that harder level at home. So I'm going to go into the relaxed mode, partly so I can talk to you about it. It just gives you 10 questions. With the timed mode, you have a time and you have to try and do as many as you can. Okay. So what you have to do is you have a little shooter. I'm on a laptop. I'm not sure how it works on a tablet, so you'll have to give it a go. But on a computer, you're just going to click your mouse to shoot the triangles. Now it tells you the type of triangle you need to look for. So this says a scalene. So you're looking for the triangles which are skew width. Now I can see one floating down here. There we go. And now I'm looking for an isosceles triangle. So 2 sides the same. Looks a bit like a mountain, could be tall and pointy or wide. I'm going to go for this one. Now it's looking for equilateral. Everything is equal, remember, so it will look like a very perfect triangle. I'm going to catch this one. Another isosceles. Let's go for a wide mountain. Skew with scalene. This one's looking pretty skew with. Another equilateral. That one looks perfect. Another scalene. Oh, there's one coming just underneath. And an isosceles. Isosceles. Oh, look at this one. That's a very tall, pointy one. And an equilateral. And a scalene. And there we go. I did my 10 goes. So you have a go at that at home. I'll put the link underneath the video. Okay, so the app that I'm recommending is called GeoBoard, which is by the Maths Learning Centre. You can download it on Apple devices, I believe. I'm not sure actually. I don't think it's available on other devices, but it is also available as a website, and you can see the link on the screen. I would also put it under the video. So I'm actually going to show you how to use it on the website, just because it's a bit easier than me doing it on my phone. So this is the website version of the app. It's most similar to if you download the app on an iPad, because the screen is bigger, you can choose between different boards and it gives you that option. On a phone, you're restricted with your screen size, so I think it just normally gives you the standard grid in the background, pegboard. There's various buttons at the bottom which you can use. There is a button that actually puts a grid on, which can be useful. I'm going to put it onto the rectangular board just to give myself some more room. So using this app or website, you can use it to practice making different types of triangle. You could even create a little quiz for yourself or your family and get them to create you triangles, and you guess the type, or you could create them triangles. So once you've popped a band on, you can drag from the middle and easily create triangles. So you could create a right-angled triangle. You could create a scalene triangle where it's all skew width and there's no sides that are the same. You could also create an isosceles triangle where you've got 2 sides the same. You can colour in, shade in the middle using this paint drop button down the bottom, if that helps you as well to see the shape in
once you've drawn it and see how it looks. I also recommend using this to create different types of polygons. So you could try to create maybe a pentagon or a hexagon or an octagon. And the good thing about this is that one of the questions in your book, which we went through earlier, the question where you had to draw onto the grid the different shapes, this could be really useful for you to practice making the shape that you need to draw before you actually draw it in your book. So you could have a play with what would be possible and then use this to help you check it. So you can pop on and create different shapes. So here I've got a 5-sided shape, which is a pentagon, but it is an irregular pentagon because the sides and the lengths, they're different. So you can use that to create different shapes, different triangles, and hopefully that will be really useful.
Now the next video is about angles, so please do tune in to that one when we'll learn the different types of angles. Also some funny names that we need to learn. So just remember, equilateral triangle, everything is equal. Isosceles, 2 sides the same on the icy mountain. A skew with scalene, where everything is different. And a right angled triangle, which, surprise, surprise, has a right angle.